pleasure to extend you a very warm welcome on behalf of our college, Marathwada Shikshan Prasarak Mandal, Yashwantrao Chavan Mahavidyalaya, Ambazogai, who has clubbed all of us for national seminar organized by Department of Chemistry on today's topic, metal ions in life from bioinorganic chemistry to term symbols. It gives me pleasure and pride to welcome and introduce our guest. We are extremely honored to have our keynote speaker of today's program, Dr. Mohan Bhai Patel sir, and research person of today's program, Professor Dr. Suresh Gaikwad sir, and chairperson of today's program, respected principal sir of our college, Dr. Shivdas Shirsat sir, and vice principal of our college, Dr. Ramesh Shinde sir and PK Jadhav sir. Metal ions in life from bioinorganic chemistry to term symbol. Bioinorganic chemistry bridges inorganic chemistry and biological, focusing on the essential role metal ions play in living system, ranging from oxygen transfer to enzymatic catalysis. These metal ions, often found at the active sites of metallisms, performs critical functions such as electron transfer, structural stabilization, and signal transduction. Understanding the behavior, reactivity, and spectroscopic properties of these ions, particularly transition metals, requires a foundation of coordination chemistry and atomic theory, often describing using term symbols to analyze electron states and magnetic properties. Metals ions are critical for life with more than 52% of protein containing metal ion such as iron, zinc and copper. May I request everyone to give them a warm welcome. Now I would like to request our respected principal sir, Dr. Shirsat sir, to give us some guidance.
Namaskar. Warm good morning to one and all. MSP Mandal Yashwantrao Chauhan College Ambajogai, Department of Chemistry, organized one-day national online seminar, Metal Ion in Life from Bioinorganic Chemistry to Term Symbols. I am grateful to all Honorable Executive Council and CDC members, the office bearers of all the organizations have given their best wishes for this seminar. Today, our guest of honor and keynote addressee of this seminar, Honorable Dr. Mohan Bhai Patel, Professor, Department of Chemistry, Sardar Patel University, Gujarat. Resource persons, my friend, colleague, Dr. S.T. Gaikwad, Senior Professor, Department of Chemistry, Dr. Babasaheb Ambedkar, Marathwada University, Chhatrapati Sambhajinagar. I first of all welcome on behalf of the college convener this seminar, Ms. Varsha Nagargoje and organizing committee, Vice Principal Dr. Ramesh Shinde, Mr. PK Jadhav, technical supporter Mr. Ali Sheikh, Mr. Asif Sheikh, my all teaching and non-teaching staff members and participants joined from various parts of country. I welcome you from my bottom of heart. It is essential to mention that Dr. Milind Gaikwad, Associate Professor in the Department of Chemistry at Rajmata Jijau College, Kille Dharur, Bid, provided immense support for today's seminar. It is solely due to his cooperation that this seminar has been made possible today. Dr. Gaikwad, our heartfelt thanks to you. Dear participants, the purpose of today's program is to have an in-depth discussions on the field of bioinorganic chemistry and to understand why life is a much related to periodic table as it is to DNA, while organic molecules from the framework of life. Metal ion, often called unsung heroes of biology, provided catholic and structural support. The biological reality is the metal ion are not merely passive passengers, they are active participants. Their role can be categorized as follow: regulations and signaling, alkali and alkyne, earth metal like sodium and potassium maintain osmotic pressure and nerve impulse, whilst calcium act as a universal trigger for cell signaling and muscles contraction. Contractions metal like iron and zinc are key component of enzymes. For example, iron in hemoglobin transport oxygens, while zinc is essential for over 300 enzymes, including those involved in DNA repair. Bioorganic chemistry shows as what and where of metals in our bodies, while term symbols explain the how by depending define their electronic structure. Understanding this link is crucial for developing better metal-based drugs and for understanding the molecular basis of life. Under this main topic, the discussions will focus on two subjects: the impact of bioinorganic chemistry on humans and plants, and other topic is being terminology, symbols, and their applications. Both of these topics are closely related to life. I hope that this seminar today will not only serve as a platform for exchanging information, but also for fostering interdisciplinary collaborations which will shape the next decade of biotechnology. Once again, thank you to all. Thank you. Jai Hind, Jai Bharat.
Thank you so much, sir. It's really proud and honor of our college to organize such a beautiful program with such as amazing guests. Words are too short to describe their achievements. Now I request to my colleague Professor Kople Madam to introduce our today's keynote speaker, honorable and respected guest Dr. Mohanbhai Patel sir.
Good morning to everyone. Good morning to everyone present here. It is a great honor and privilege for me to introduce today's distinguished guest and eminent speaker, Dr. Mohanbhai N. Patel, an renowned academician and researcher in the field of inorganic chemistry. Dr. Patel is currently serving as a professor of chemistry at the Department of Chemistry, Sardar Patel University, Vallabh Vidyanagar, Gujarat. He has also shouldered important academic responsibilities as convener of the API Committee, coordinator of IQAC, and chairman of the Board of Studies. contributing significantly to academic planning and quality assurance. Born on 14 January 1963, Dr. Patel completed his graduation, MPhil, and PhD from South Gujarat University with his doctoral researcher focusing on studies in some heterochelates. His strong academic foundation laid the path for an illustrious career in teaching and research. With more than 3 decades of teaching and research experience, Dr. Patel sir has served the academic community in various capacities, starting as a lecturer, progressing to reader, and presently as a professor. His commitment to education and mentorship has shaped the careers of many students and researchers. Dr. Patel sir research expertise lies in bioinorganic chemistry, coordination chemistry, and coordination polymers. He has an outstanding research profile with 180 research publications in national and international journals. He has successfully guided 28 PhD students and has an impressive research impact with an H index of 35, I-10 index of 126, and more than 3,800 citations. His scholarly excellence has been recognized through several prestigious honors, including the Hari Om Ashram, Prerit Bhai Kaka Inter University Smarak Trust Awards. He is also a recipient of the UGC BSR one-time grant, acknowledging his significant contributions to chemical research. Today, we are truly fortunate to have with us a scholar who is not only an exceptional researcher but also a dedicated teacher and academic leader. I am a confident that his talk will be highly enlightening and inspiring for all of us. Please join me in extending a warm and respectful welcome to Dr. Mohanbhai Patel sir. Thank you.
Thank you so much, madam. To know more about today's topic, organized by College and Department of Chemistry, I like to request Dr. Mohanbhai Patel sir to deliver speech on the topic term symbol and its application.
Okay. Thank you, ma'am, for nice introductions. And I'm also thankful to organizer for giving me an opportunity to talk on term symbols and its applications. So it is visible to us. My skin is visible.
Yes, sir.
Okay. So my topic is term symbol and its applications. So in inorganic chemistry, the coordination chemistry is more important part. And to understand the coordination compound, the turn symbol is more essential. To characterize the coordination compound, the electronic spectra is more important. To understand electronic spectra, the term symbol is essential. From term symbols, we can know about the ground term, ground state, and from transitions. And from the on the basis of transitions, we can determine the structure, whether it is octahedral, tetrahedral, or so on. So, term symbol is most important part in coordination chemistry. Now the symbol for the term symbol is 2s plus 1 Lj. So this is three term 2s plus 1 L and J. So here this 2s plus 1 is called spin multiplicity. It indicates the number of unpaired electrons and number of way in which this electron can be arranged. So means from this 2s plus 1 we are getting two informations. So how many unpaired electron is there, and what are the how many way in which this unpaired electron can be arranged. Suppose 2s plus 1 is equal to 1 means only one indicate there is only one arrangement and there is no electron, means no electron and that is only one arrangement. So similarly 2s plus 1 is equal to 2 means, so there are two arrangement and only one electron. So one electron is arranged by two way, that is up spin and down spin. This is the two arrangement. So similarly 2s plus 1 is equal to 3 means there are three arrangement and the number of electron is 2. How it is 2? 2s plus 1 is equal to 3 means 2s is equal to 2 and 2s is equal to 2 means s is equal to 1 and s is equal to means, so plus 1 half and plus 1 half means there are two spin means two electron and these two electron can be arranged by three way. The first one is both electron with up spin, both with a down spin and up and one down. So this is the three arrangement. So similarly we can say that 2s plus 1 is equal to 6 means there are six arrangement and there are 5 electron, means 2s plus 1 is equal to 6 means 2s is equal to 5 and s is equal to 5 by 2 means there are a 5 unpaired electron. So similarly another symbol is L. So L represent the resultant orbital angular momentum. L is the resultant orbital angular momentum and the value of L is equal to 0, 1, 2, 3, 4, 5, 6 and 7 and accordingly symbol is S, P, D, F, G, H, I. Here the J is missing because J is the total angular momentum, so therefore there is no J and next one is the K, means L is equal to 7 means your symbol will be a K. So here the J is called a level and how will you determine the value of J? So J value is determined from L plus S, L plus S minus 1, L plus S minus 2 and so on, and the last one is mode of L minus S, means whatever the positive value, the lowest one. So here, so there are number of value for J. So lowest value of J we have to consider for half fill or less than half fill system. So if your system is half fill or less than half fill, so then we have to consider the lowest value of J, that is L minus S. So in case of more than half fill, we have to consider the highest value of J. So from L, so there are only one value, that is the highest value of J or lowest value of J. Number of J value are more, but if your system is half fill or less than half fill, then we have to consider the lowest value of J, that is the mode of L minus S. And if your system is more than half fill, suppose it is a D6, D7, D8 or D10 system, then we have to consider the highest value of J, that is L plus S. So now derivation of term. So first we start with the S electron. So for S electron, we know that L value is 0, means ML value is 0. So S1 means single electron system, L value is 0, means one electron is present in ML value 0. So one electron is upfin means S value is 1 half. So then multiplicity 2s plus 1 will be 2 means S is equal to 1 half means multiplicity is 2. ML is 0 means L is 0 and J value is only L plus S, that is 1 half. Then your symbol will be doublet S 1 by 2. So here spin multiplicity 2s plus 1 can be called as a doublet, not it is 2, it is doublet S 1 by 2. So similarly in case of S2 system, is 2 electron present in a S orbital, so ML value is in ml value 0, both electrons are present with up and down spin. So in this case, the s value is 0, means plus 1/2 minus 1/2, s is 0. Then multiplicity, there is no unpaired electron, so means s is 0, but 2s plus 1 is equal to 1, means multiplicity is 1. L value is again 0. J value is L plus S, and it is also 0. And your symbol is singlet S0. So this is for a S electron system. So similarly for P electron system, as you know that there are P means 3 orbital, and the ml value is ranging from +1, 0 and -1. S value is determined from number of unpaired electron. So now in case of P1 system, only one electron is there and one electron present in ml value 1. So in case of S value, so one unpaired electron is there, means S value is 1/2. And S is 1/2 means multiplicity is 2. Electron present in ml value 1 means L is equal to 1. J value is L plus S to mode of L minus S. So means here there are two value of J, 3 by 2 and 1 by 2. Now here it is a less than half fill system, means your term symbol will be doublet P 1/2. So we have to consider 1/2 instead of 3 by 2 because it is a less than half fill. So similarly in case of P2 system, so there are two P electron, one P electron present in ml value 1 and another one in ml 0. So S value is 1 because it is a plus 1/2 and plus 1/2, both electron with a off spin. Multiplicity is 3 because S is 1. L value is 1 because one electron present in ml value 1, another in a 0, means summation of ml is 1. Here J value is L plus S to mode of L minus S. So J value is ranging from 2, 1 and 0. So then your symbol will be triplet P0. Here we have to consider 0 because it is a less than half fill. So similarly in case of P3 system, so there are 3 P electron. All are present in ml value 1, 0 and -1. So there are 3 unpaired electron, means S value is 3 by 2. Then multiplicity will be 4. So here L value is 0 because it is summation of ml, L plus ml plus 1 -1 0. So therefore summation of ml is 0 and your J value is only 1, that is mode of L minus S, that is 3 by 2. And here your symbol will be quartet S 3 by 2. Here also it is a half fill, then and there is only single value, so we have to consider 3 by 2. So now P4 system, there are 4 P electron, 2 electron are present in ml value 1 and rest of 0 and 1. So there are 2 unpaired electron, means multiplicity is 1. Spin multiplicity is 3 because of 2 unpaired electron. Here L value is 1 because, so here the summation of ml means ml 2, 0 and -1, means summation of ml is 1. Then the J value will be 2, 1 and 0 and the symbol is triplet P2. So here it is a more than half fill, means we have to consider the highest value of J and therefore it is 2. So here you can see that the P2 and P4 system having a same term symbol triplet P except the J value, both having a same term symbol because of it's having a same L and S value, both having a same L and S value 1 1 each, and therefore they having a same term symbol, and it is also known as a whole equivalent or whole formalism. So P2 and P4 system having a same term symbol because they having a same L and S value, except the J value is 0. A J value is different because it is one is half fill and less than half fill and more than half fill. For similarly in P5 system, so 5 P electron is accommodated in ml value 0, -1. Here S value is 1/2 because only one unpaired electron. So multiplicity is 2 because of 1 unpaired electron. L value is here again 1 because Ml value 1 having a 2 electron, Ml value minus 1 having a 1 electron. So summation of Ml will be 1. Here J value is 3 by 2 and 1 by 2. So what will be the term symbol here? So it is a doublet P 3 by 2. So here we have to consider the highest value of J, that is the 3 by 2. Here again you can see that the P1 and P5 having a same term symbol, doublet P, except the J value is different because the one is half fill, less than half fill and more than half fill. So similarly here the both having a same S and L value, 1/2 and 1, 1/2 and 1 means same L and S value, and therefore they having a same term symbol, and it is called Hall equivalent or Hall formalism. So similarly in p6 system all orbital are occupied paired, so therefore there is no unpaired electron. S is 0, multiplicity is 1, no unpaired electron, L value is 0, J value is 0, and here symbol is singlet as 0. So this is for a p-electron system. Important point here, P1 and P5 having a same term symbol. Similarly, P2 and P4 having a same term symbol because they having a same L and S value. So similarly for d electron system, for d electron there are 5d orbital, and therefore ml value is ranging from +2 to -2. So there are 5 ml value. Now in case of d1 system, so first electron present in ml value 2, and here it is only one unpaired electron, means S value is 1/2, multiplicity is 2, L value is here 2 because electron present in a ml value 2, J value is 5 by 2 and 3 by 2, and the term symbol is doublet D 3 by 2. So here we have to consider 3 by 2 because it is a less than half fill. So similarly for D2 system, 2 electron are present in a ml value 2 and ml value 1. So means there are 2 unpaired electron. The S is 1. Multiplicity is 3 because of 3 unpaired electron. L value is L plus S. L value is 2 plus 1, therefore 3. J value is L plus S to mode of L minus S, that is 4, 3, 2, and symbol will be triplet F2, less than half fill. So here L value is 3 means it is symbol is S, P, D and F, therefore 3 for F. So from D3 system, 3 unpaired electron, so means multiplicity is 3, multiplicity is 4, and here L value is summation of ml plus 2 plus 1 and 0, and therefore it is 3. J value are 9 by 2 to 3 by 2, so there are 4 J value. So it is a less than half fill. We have to consider the lowest value of J, that is the 3 by 2, and the symbol is quartet F 3 by 2. Similarly for D4 system there are 4 electrons and 4 unpaired electron, means S is 2, multiplicity is 5, and L value is 2. It is summation of ml 2, 1, 0 and -1. So summation is 2. J value is 4, 3, 2, 1, 0, and your symbol is quintet D 0 because it is a less than half fill. We have to consider lowest value of J. So for D5 system, so 5 unpaired electron means S is 5 by 2, multiplicity is 6, L value is 0 because all electron present in ml value 2 to -2, so summation is 0. J value is 5 by 2 and symbol is sexlet S 5 by 2. So similarly it can be happen for D6 to D10, and similarly here D1 and D9 having a same term symbol because they having a same LSS value. Similarly for D2 and D8 having a same term symbol, that is a triplet F. D3 and D7 having a same term symbol, that is quartet F, and D4 and D6 having a same term symbol, that is a quintet D, except the J value is 0. So here you can see here from D6 to D7. So D6 it having a quintet D, it is similar to D4. D7 having a similar to D3, that is quartet F. D8 having a similar to D2, that is triplet F. D9 having a similar to D1, that is a doublet D. And D1, D10 having a singlet S. So means, so there is only, you can say, three type of term: D, F, and S. So there are four term belongs to D, four belongs to F, and two belongs to S. So means D1, D4, D6, and D9 having a D term. The multiplicity is either doublet or quintet. In case of D2, D3, D7, and D8 having a F term, and multiplicity is maybe either triplet or quartet. So multiplicity is determined by number of unpaired electron plus 1, means 2s plus 1, 2s plus 1 means, so suppose 1 unpaired electron means doublet, 4 unpaired electron means quartet, 6 unpaired electron. So in case of D6 there are 4 unpaired electron means it is quartet, and suppose it is a 6 unpaired electron in case of F electron system, 6 unpaired electron, then it is a 7. But we are talking about a D electron. So maximum unpaired electron is 5, means it is a maximum multiplicity will be 6. So means it is quite easy to remember. So D1, D4, D6, and D9 having a D term, D2, D3, D7, and D8 having a F term, and multiplicity is either in case of D1 doublet and quintet, in case of F term it is a triplet of F. So as you know that here similarly Dn and D10 minus n are same, are known as a whole equivalent or Hor formalism, because they having a same L and S value. So here the determination of term symbol is quite easy. So summation is, so all in case of D10 system, so there are three type of term: S, D, and F. So S means D5 and D10 having S term, D1, D4, D6, and D9 having a D term, and D2, D3, D7, and D8 having a F term. It is, you have to remember. Now, so correlation diagram is the one of the most important points for determining the ground state. So here we determine the ground term. So on basis of ground term, so we have to determine the ground state. So always the transition is take place from ground state to higher energy state. So the ground state is most important point to determine. So there are different kind of ground state. Either it is a T1, T2, E, or A1, A2. So this ground state can be determined from the correlation diagram. So here you can see that the correlation diagram shows the correlations that exist between the state derived from the free metal ion and the state derived from the strong field configuration. So now in role of this correlation diagram to determine the ground state, which term is your ground state. So suppose your energy difference, here you can see the correlation diagram for this D1 system. So D1 system, the ground term is doublet D, and D term, that is in crystal field, it's split into T2G and EG, or T2 and EG. So multiplicities remain same, whatever the free answer means doublet doublet. So in case of strong field configurations, so this single electron can be accommodated either in T2G orbital or a EG orbital. Okay, so in T2G orbital is there, means it is a only single electron, means it is doublet, and similarly single electron in EG orbital it is a EG. So here you can see that, so this in correlation diagram, the higher energy means same term, same multiplicity term, and same symmetry multiplicity term are correlated or attached with the same, means doublet EG is attached with the doublet EG, similarly doublet T2G attached with triple T. So here the doublet T2G is associated with the 4 DQ and EG is associated with the 6 DQ. And therefore, whenever your energy difference is 6 dq, your ground state will be Eg. And whenever your energy difference is 4 dq, your ground state will be a T2. So these informations we are getting from the correlation diagram. So this is the use of correlation diagram. So on the basis of correlation diagram, we can determine the ground state. And from the ground state, we can determine the transition. So means your energy difference is 4 dq. Suppose a D1 system. In D1 system, the electron are accommodated in T2g orbital. And if the T2g orbital, in electron present in T2g orbital, the energy is 4 dq. If electron present in a EG orbital, the energy is 6 dq. So single electron present in a T2g orbital means in case of D1 system, the energy is 4 dq. And if for the D1 system, your ground state will be a 4 dq. So similarly, in case of a D4 system, what is the electronic configuration that T2G1, EG1? So T2G1 means 3 electrons are present in T2G orbital, means total energy is 12 dq. So 1 electron present in EG orbital, that is a 6 dq. Difference is 6. So means if there are energy difference is 6, then your ground state will be 6. So this information we are getting from the correlation diagram. Means if your energy difference is 4 dq, your ground state will be T2. If your energy difference is 6 dq, your ground state will be EG. So similarly for D2 system, so these are the correlation diagram. So it is a very long topic. It is also required to understand 1.5 hour. Suppose I am explain. So simply here I will show the correlation diagram. So in correlation diagram D2 system, so as you know that there are 45 microstate, and this 44 microstate described by triplet F, singlet D, triplet P, singlet G, and singlet S term, and they are arranged according to this experimental energy. So in case of strong field configuration, so there are two electron system. These two electron either present in T2G2 orbital. So if both electron are present in T2G orbital, the energy difference will be 8, or energy is 8. Suppose one electron present in T2G orbital or one in EG, so energy difference is 4. So T2G, so 4 dq, EG 6 dq, that is minus 6 dq, means difference is 2 dq. Then in case of both electron may be present in a EG orbital, means electron present in EG orbital 6 into 2 means 12 dq. So similarly here this can be determined. It is a long procedure. So here this identical state are connected with the straight line. So important point is, so what information we are getting? So suppose your energy difference is 12 dq, then your ground state will be A2G, because here you can see that in triplet F there are three states T1G, T2G, and T2G, A2G. So transition is take place within the same velocity, that is T1G to T2G to triplet A2G, and here this is the triplet A1G. These are the spin allowed transition. Rest of it is forbidden. I discuss later on. Means three transition expected. Here the A2G is associated with EG2. And energy of EG2 is 12 dq, means whenever your energy difference is 12 dq, your ground state will be A2G. So suppose in case of D3 system, 3 electrons are present in a T2G orbital, means energy is 12 dq, means whenever your energy difference is 12 dq, your ground state will be A2G. And similarly this T1G associated with the here 8 dq, T2G2 means 8 dq, means whenever the energy difference is 8 dq, your ground state will be T1G. So suppose in D2 system the energy is, electronic configuration is T2G2. So T2G2 means energy is 4 into 2, 8 dq, and whenever your energy is 8 dq, the ground state will be T1G. And here you can see the transition. In case of D2 system, the transition is takes place from T1G to T2G to A2G and quartet T1G. Means this is the state of a same multiplicity. So first here in this diagram you can see that energy of A2G is 12 dq, energy of T2G is 4 dq, that is from spherical field. Energy of T1G is 6 dq. So here this 12 dq, 2 dq and 6 dq, it is required to remain maintain the center of gravity. So whatever the energy is above for T2G and E2G, the same kind of energy should be for T1G. So T1G is triply degenerate, means 3 into 6, that is 18 dq. A2 is the singly degenerate, means 12. Again T2G is triply degenerate, means T means 2 into 3, 6, means 12 into 6, 18. 6 into 3, 18, means whatever the energy above, same kind of energy is below. Means therefore nu1 is from transition takes place from this 6 plus 2, means T1G2, T2G, that is 8 dq. Nu2, that is the 18 dq, means nu2 transition takes place from T1G2 quartet A2G, means 12 plus 6, that is the 18 dq. So similarly nu3, that is the transition takes place from T1G to T1G, quartet T1G to T1G. So here the term is T1G is associated with F term is T1GF. The second one is T1GP. So third transition is quartet T1G to quartet T1GP. So this is the 15B, that is called Raka parameter or inter-electronic repulsion parameter plus 6, means 15B plus 6 dq. So here these three transition is, first nu1 is 8 dq, nu2 is 18 dq and nu3 is 15B. So ground state, as I discussed here from correlation diagram, so we can determine the ground state. So here for S term, the crystal field term is A1 because S orbital is only 1. P orbital, so there are 3 P orbital and therefore it is the symbol is T. As we know that A for singlet, E for doublet and T for triplet. So similarly for D orbital, there are 5 D orbital split into E and T2. E means doubly degenerate, T for triply degenerate, means 2 plus 3, that is 5. So similarly one can say for F orbital, that is 7 orbital, so means 2 plus 3 plus 3. Okay, 3 plus 3 plus 2, 1. That is the 7. So similarly in case of G orbital, so G orbital will be 3. Sorry, 9. So means it is split into A1, E, T1 and T2. Means 3 plus 3 plus 2 plus 1, that is 9. So similarly in case of H orbital, so it is a 11 sets of orbital and it is split into E, T1 and T2. Means 3 for T2, there are 2 T1, that is 6, and E the 2, means 2 plus 6 plus 3, that is 9. And similarly in case of I term, so it is a 13, I orbital 13, A1, A2, E, T1 and twice T2, means 1 plus 1 plus 2 plus 3 plus 6, that is a 13. And these are the crystal field term. So here we know that S, P, D, F, G, these are the term, and A1, T1, E, T2, these are the state term. This is the basic difference between ground term and ground state. So ground state of complex can be derived from the ground term of free metal, and that is SPDFG. So multiplicity of complex remains same for free metal ion. So as we getting information from correlation diagram, whenever your energy difference is 4 dq, ground state will be 2. Whenever energy difference is 6 dq, ground state will be E. Whenever energy difference is 8 dq, the ground state will be T1. And whenever the energy difference is 12 dq, ground state is A2. And whenever 0, the ground state will be A1. And all these informations we are getting from the correlation diagram. And this is the application or use of correlation diagram. So on basis of correlation diagram, so we can get the idea of a ground state. So it is very simple way to remember what will be the ground state. So ground term we can determine for D1 system. Generally, in case of octahedral transition metal complexes, ground term will be either S, D, or F. But the ground state will be T1, T2, E, A2, and A1. So whenever your energy difference is 4 dq, remember that your ground state will be T2. Whenever energy difference is 6 dq, ground state will be E. Whenever your energy difference is 8 dq, ground state will be T1. Whenever energy difference is 12 dq, ground state will be A2, and 0 in case of A1. So these informations we are getting from the correlation diagram. Now in case of D1 system, so ground term is doublet D. The what will be the electronic configuration? So that is the T2G1, and D orbital that is split into E and EG and T2G. We are talking about octahedral, therefore we say that T2G and EG. So what will be the ground state, or which from T2G or EG, which one is the ground state? So electronic configuration from for D1 system is T2G1. T2G1 means energy is 4 dq, and whenever your energy is 4 dq, your ground state will be T2G. So in case of D1 system, so transition is take place from T2G to EG, isn't it? So this is also known as a Oracle diagram. And similarly for D6 system, the ground term is quintet D. Again, this quintet D split into T2G and EG. So here electronic configuration is T2G4 and EG2. So T2G4 means energy is 4 into 4, that is 16 dq. EG means 6 into 12, 6 into 2, 12, means energy difference is 16 minus 12, that is 4. And whenever energy difference is 4, means the ground state will be T2G. So means the ground state is T2G, and higher energy term is 6D, higher energy term is EG. And therefore here also one transition is takes place from doublet T2G to doublet EG. So similarly in case of D9 system, the ground term is doublet D. What will be the ground state? It is decided on the basis of ground state electronic configuration, and the ground state electronic configuration is T2G6 EG3. So T2G6 means energy is 24 dq, EG3 means 18, difference is 6, and whenever energy difference is 6, your ground state will be EG. So here the transition is take place from doublet EG to doublet T2G. Similarly, in case of D4 system, the ground term is doublet D. Electronic configuration is T2G3 EG1. Energy difference is 6, that is 12 and 6 means 12 minus 6 means 6. 6 means transition is take place from quintet EG to quintet T2G. So here the ground state for D4 and D9 are identical except multiplicity. What is the reason? Because in case of D4 having a one hole in half fill, in case of D9 there is a one hole in a full fill, so therefore both having a same energy. D4 energy difference is 6, D9 energy difference is 6, and therefore they having a same ground state, that is EG. So term symbol is different, means the so D4 having a quintet D, D9 having a doublet D. So term ground term is different, that is the multiplicity is different. Term is the same D, but all the ground term is different because of they having a same L and S value, a different L and S value, therefore ground term is different. But here energy is same because they D4 having a one hole in half fill, it is D4, D9 one hole in a full fill, and therefore the energy is same, and therefore they having a same ground state or same Oracle diagram. So similarly, it is applicable for D1 and D6. In D1, 4 hole in half fill. D6, there are 4 hole in a full fill, and therefore they having a same energy, and therefore they having a same Oracle diagram or ground state. So now combined diagram for D1, D4, D6 and D9 can be shown by here. So term is D. So this diagram, right hand side is applicable for D1, D6 octahedral or D4, D9 tetrahedral. In both the case, the energy is 4dq, that is transition is taking place from T2 to E. So in case of left hand side, diagram is applicable for D1, D6 tetrahedral or D4, D9 octahedral, because the energy difference in both the all the case is 6 dq. Therefore transition is takes from ground state is E to T2. Now in case of D2 system, so D2 system, there are more number of microset, and there is, and then we have a same term. So 45 microset, and the term will be triplet F, triplet P, singlet D, singlet G, and singlet S. There are 5 term, but here we are considering only a higher multiplicity term or only one term, because we are considering only a allowed transition. So forbidden transitions also there, but it is less frequently observed. So we observe only strong transition, that is the allowed transition. So here the this two term triplet F and triplet P having a same multiplicity. So in case of D2, D3, D7 or D8 system, so we have to consider this two term F and P. So as we know that F term is split into T1G, T2G and E2G. So there are three term T1G, T2G and E2G. So what will be the ground state? So D2 system, the electronic configuration is T2G2. So T2G2 means energy difference is 8 dq. And whenever energy difference is 8 dq, your term will be a T1. So here you can see that this triplet T1GF term is slightly curved, and therefore that is due to the repulsion between the state of same symmetry and multiplicity. So energy of this higher energy term is slightly increased. Similarly for D7 system, so here also we have to consider quartet F and quartet P term, because there are two different term of a same multiplicity. So here the energy difference is also a dq, because the electronic configuration T2G5 Eg2. 5 means 20, Eg2 means 12, means energy difference is 8 dq, and therefore the transition is takes place from quartet T1G to quartet T2G, quartet T1G P and quartet A2G. So here also quartet T1G is slightly curved because of repulsion between state of same symmetry and multiplicity. So here you can see that the D3 and D7 system, D2 and D7 system having a same diagram, because the ground state energy is same. Both having a different ground term. One having a triplet P, another having quartet F. But the ground state are same, that is T1G in both the case T1C except multiplicity, because of a same energy. So similarly in case of D3 system, the ground term is quartet F and quartet T. But here compared to D7 system, so here the ground state is changed, that is a quartet A to G, because ground state electronic configuration is T2G3. So whenever T2G3 is there, the energy is 12 dq. When the energy is 12 dq, means your ground state will be A2G. So here all these transitions are changed. Transitions take place from quartet A2G to quartet T2G and quartet T1G, and last one is quartet T1GP. So similarly for D8 system, this diagram is quite similar to a D3 system, because the energy difference are same. The energy difference is 12 dq, because electronic configuration is T2G6 Eg2. T2G6 means 24 and Eg2 means 12. Energy difference is 12, means here the transition is takes place from triplet A2G to triplet T1G. Okay, so you remember that the ground term and ground state are quite different. So these are the combined diagram for D2, D7, D3 and D8. So here the right side is applicable for D2, D7 octahedral and D3, D8 tetrahedral. So here the transition in all these four state take place from T1, G2. So we are not mentioning G because it is applicable for octahedral and tetrahedral, T1 to T2, T1 to T1P and T1 to A2. So similarly, the left hand side is applicable for D2, D7 tetrahedral and D3, D8 octahedral. So this is the combined diagram for or regal diagram for this system. Now selection rule. As you know that there are number of term, there are number of term having a different multiplicity. So means the theoretically number of transition are more, but this theoretically expected all transition are not observed, because transition is formulated in a sets of selection rule which distinguish as a allowed and forbidden transition. So allowed transition are most commonly observed, while the forbidden transition are less frequently observed with a weak intensity. So there are four sets of rules. The first one is Laporte orbital selection rule. So in case of Laporte orbital selection rule, if the transitions which involve in a change in a subsidiary quantum number L are said to allowed transition, means delta L is equal to 0 during the transition. These are known as a allowed transition. For example, in calcium, so transition is takes place from S2 to S1P1. In this case, L is changed from 0 to 1. That is called, there is a change in a L value, and therefore it is known as a Laporte allowed transition. But in case of transition metal complexes, all transition are Laporte forbidden, because the transition which does not involve in change in a subsidiary quantum number are said to a Laporte forbidden, means delta L is 0. So DD transition are Laporte forbidden, because in case of D, L value is 2. 2 2 means DD means 2 to 2 transition, L value is 0, and therefore there is no change in L value, and therefore the transitions are known as a Laporte forbidden. If L value is changed, then it is Laporte allowed. If L value remains same, then that is called a Laporte forbidden. But in case of octahedral complexes, center metal atom is surrounded by 6 ligand, and there is some mixing of d and p orbital occur. So in this case, the transition are not purely in dd in nature. So therefore, so they are also known as a partly Laporte allowed transition. So for example, so the mixing of d and p orbital is occur in case of non-centrosymmetric complexes like a tetrahedral complexes or a substituted octahedral complexes, in which case all ligand are not same. So there is the chloropentamine cobalt 3 complexes. There is no centrosymmetric. So these transitions are not purely DD in nature. So these transitions are known as a partly Laporte allowed transition, not a Laporte forbidden transition. Or you can say also partly Laporte a forbidden, but most generally it is speak as a partly Laporte allowed transition. Means all these tetrahedral complexes. So this there is a mixing of d and p orbitals take place. So therefore, these transitions are known as a partly Laporte allowed transition. Or octahedral complexes, substituted octahedral complexes, means all the ligand are different. Then this transition are known as a partly Laporte allowed transition. But if they're all ligand are same, for example, hexamine cobalt 2 complexes. So in this case, the all ligand are same, but there is no mixing of d and p orbital take place. But in this case, the metal ligand bond is vibrate, and ligand spend some time out of centrosymmetric position. So there is a small mixing of d and p orbital take place, and in this case, very weak band is observed. But this kind of transition is known as a Laporte forbidden transitions. Now, spin selection. It is also true. If the transition which involve in change in spin multiplicity, that is delta S is not equal to 0, that is called spin forbidden transition. And the transition which involve in change in a multiplicity, that is the delta S is zero, then it is called spin allowed transition. Which means it's completely opposite to Laporte allowed. Means delta L is zero, then it is delta L is zero, then it's a Laporte forbidden transition. If delta L is equal to zero, that is a spin allowed transition. If delta L is not equal to zero, then it is spin allowed transition. And if delta S is not equal to zero, then it is spin orbital. So means you have to remember one thing, and second part is exactly applied opposite. Delta L is zero, that is the spin forbidden transition. Delta L is not zero, it is sorry, it is Laporte allowed transition. Delta S is zero, it is spin allowed. Delta S is not zero, that is a spin forbidden transition. So for in case of D5 system, so ground state in case of the manganese D5 system, the ground as Saxelate S, but there is a no term of same electricity at higher energy level. So to find out the transition in this case D5 system, we have to consider the next higher energy term, and the next higher energy term is quartet G. So here in this case, the transition is take place from Saxelate S to quartet G. So here the energy difference is delta S2. Means this kind of transition is known as a spin forbidden transition. Okay. So here also it is a transition from in case of this triplet F to triplet P term. So in case of a D2 system, so delta S is zero because there is no change in a spin multiplicity, triplet to triplet, and therefore this kind of transition is known as a spin allowed transition. So for example, in cobalt 2 complexes, the transition is take place from quartet F to quartet P, means there is no change in a multiplicity quartet to quartet, and this kind of transition is known as a spin allowed. So in case of D5 system, delta S is 2, means it is a spin forbidden transition. In case of cobalt 2 complexes, delta S is zero, quartet to quartet, and therefore this type of transition is spin allowed transition. So in case of this manganese 2 complexes, so transition is doubly forbidden. And as you know that the salt of manganese are light pink in color because of very weak intense band, because it is a doubly forbidden transition. How it is doubly forbidden transitions? It is a doubly forbidden transition because as in case of delta S is zero and delta L is also zero. So it is a doubly forbidden transitions, and therefore due to this doubly forbidden transition, intensity is very very weak, and therefore so salt of this manganese are very light pink in color. Now interpretation of electron spectra. This is one of the important application of this term symbol. So on basis of term symbol, we can determine the ground term, and on basis of ground term, we determine the ground state, and the basis of ground state, we determine the transition from ground state to higher energy system, and on the basis of the transitions, we can determine whether your determine the your structure of complex, whether it is octahedral, tetrahedral, or so on. So now in case of D1 system, so means titanium 3 or scandium 2 that belongs to D1 system. So D1 system means your ground term is doublet D, and doublet D is split into T2J and EG. As we discussed earlier, the transition is take place from ground state to high energy state. So D1 system means the energy difference is 4dq, means the transition is take place from doublet EG to doublet EG. So only one transition observed. So here it is a spin allowed transition because there is no change in spin multiplicity, that is doublet to doublet, and it is a Laporte forbidden transitions. So here not a Laporte forbidden transition because it is a DD transitions. For example, in hexaqua titanium complexes, so it is a central uh, symmetric complex, means all these transitions are DD. So two band is observed, band with a solder is observed about 20,400 and 19,600. So here the solder is observed because because it is due to a Ian-Taylor distortion, because here T2G orbital is asymmetrically filled, so that there is a no Ian-Taylor effect, and as a result, if there is no Ian-Taylor effect, then the single band is observed between these two bands. Here the slight distorted structure is observed because of T2G orbital is asymmetrically filled. Only T2G, only one electron is there. So in case of D1 system, only one band you can say observe, and that is, or only one transition observed, that is doublet T2G to doublet EG. So similarly, in case of D9 system, that is a hexa aqua copper 2 complex. So here also transition is takes place from doublet EG to doublet T2G. Why it is doublet EG? D9 system energy difference is 6. Ground term is quintet D, doublet D, and is split into EG and T2G. So EG is the ground state because of energy difference is 6. So transition is take place from doublet EG to doublet T2G. So it is a spin allowed transition because there is no change in a spin velocity, doublet to doublet. And it is the Laporte forbidden transition because it is a DD transition. Here also a band with a shoulder is observed at about 9,600 centimeter and to 12,400 centimeter. So here the EG orbital are asymmetrically filled, means EG3. EG orbital are asymmetrically filled, and therefore it is very sensitive to Ian-Taylor distortion. And therefore a band with a shoulder is observed. Now in case of D7 system, it is a cobalt complexes belongs to D7 system. So here the 3 spin allowed and Laporte forbidden transition observed. D7 system, your ground term will be quartet F, and the transition is take place from quartet T1G to quartet T2G, quartet A2G, and quartet T1GP. So your ground state is quartet T1G. Why? Because the energy difference is 8dq. Electronic configuration T2G5 EG2, energy difference is 8dq, and therefore here these 3 spin allowed transition is are observed, and all these transitions are Laporte forbidden because it is a DD transitions. So these are the diagram on the basis of we can determine, already discussed earlier. So this new one is energy of new one is 8dq, nu 2 is 18dq, and nu 3 is 15b plus 6dq. Because transition take place at T1G to T2G, T1 to A2G, and T1G to T1GP. P means it is derived from P term. So now in case of D2 system, so also 3 transitions are observed, that is triplet T1G to triplet A2G, triplet A2G, and triplet T1G. So here the ground state is T1G because energy difference is of AdQ, because electronic configuration T2G 2. So difference is 2. AdQ means energy difference. T1G is the a ground state, and here also this transition are spin allowed because it is take place from triplet to triplet, and all these transition are a DD transition, therefore it is a Laporte forbidden transition. Similarly for D3 system, your ground term is quartet F, and F term is split into T1G, T2G, and A2G. So ground state is A2G because of energy difference is 12dq, electronic configuration T2G 3. So here the 3 transitions are observed, that is about 17,000, 25,000, and 37,000 centimeter ignores. So it is a spin allowed, as we discussed earlier. There is no change in velocity and Laporte forbidden. Therefore, it is a DD transition. So here you can see the diagram is different from D2 and D3 because here the ground state is A2. Means this diagram is completely inverted. And as you know that the energy is remains same. Whatever the energy is above the spherical field, same energy should be on a down. So 6 into 3, 18 dq. 2 into 3, 6, and it is 12, means 18 and 18 dq. So here the ground state is A2G, and therefore this diagram is inverted compared to D2 and D7. So same diagram is applicable for D2 and D8. So here the transition is take place from A2G to T2G, T1G F, and T1G T1GP. So as discussed in D3 system, D8 also transition is take place from triplet A to G to triplet T2G, triplet T1G and triplet T1G P. So here also three transitions are observed at 7700 centimeter inverse, 12,000 centimeter inverse and at 24,000 centimeter inverse. So all these transition as discussed, it is a Laporte, forbidden and spin allowed transitions. So these are the diagram as discussed earlier. Now in D4 system. So D4 system, the ground term is doublet D. Doublet D is split into EG and T2G. So here the ground state is EG because the electronic configuration is T2G3 EG1, and therefore energy difference is 6 dq. Therefore transition is takes place from quartet EG to quartet ED. It is a spin allowed because there is no change in molecularity, and it is a Laporte forbidden because of a DD transitions. And similarly, it is applicable for a D6 system. But here the ground state is T2G because here the energy difference is 4 dq. Because electronic configuration, what is the electronic configuration? That is a T2G4 EG2. 4 means 16, EG2 means 12, difference is 4. So all these transitions are spin allowed because there is no change in molecularity, and Laporte forbidden because of a DD transition. Now D5 system is a special case. There is only one term, ground state is ground term is accelerated as is split into, it is a non-splitting term, and Saxlet S is split into Saxlet A1G. There is a no state of higher molecularity, so we consider the quartet G. G term split into A1G, EG, T1G and T2G. So here we cannot expect the spin allowed transition because there is a change in the molecularity from Saxlet S to quartet G. There is a delta S value is 2. Therefore, it is a spin forbidden transitions, and it is a DD transition because it is also a spin for Laporte forbidden transitions. So in this complex also we expect a 4 transition, that is a Saxlet A1G. A1G, that is this term is derived from Saxlet S, and this 4 term that derived from quartet G, that is T1G, T2G, EG and A2G. So these 4 transition are observed. So this intensity of this transition are very weak. So in all case, these 4 transitions may not be observed because of a doubly forbidden a transitions. So there are two type of term symbol as we discussed earlier. That is the atomic term symbol and the term symbol for molecule. This molecular term symbol is also important for a molecular spectroscopy. So this term symbol, atomic term symbol and molecular symbol is similar in a like symbol, term symbol. So here the term symbol for molecule is 2s plus 1 lambda and symmetry. So this is the basic difference. Only 2s plus 1 is same for both the system, atomic term symbol and molecular symbol. 2s plus 1 is same. In place of lambda, in place of L value, here it is lambda. In place of J value, here it is the symmetry. That is the basic difference between lambda and symmetry. So this symbol is known as it is a capital lambda. So the 2s plus 1 is same, that is a spin modicity. It indicates number of unpaired electron, number of way in which electron can be arranged. So this is the difference from atomic term symbol. This is the symbol lambda. It is called capital lambda. And it can be determined from the summation of ml value. So ml value is 0 plus or minus 1 plus or minus 2. And the basis of this one, the lambda value can be determined. So suppose in case of P6 system, so there are 6 p electron all occupied in ml value 1, 0 and minus 1. So here the summation of ml value is 2, summation of ml value is 0 and summation ml value is minus 2. So altogether the summation of ml is 0 and therefore the symbol of lambda is sigma, because if the lambda value is 0, then it is sigma. If lambda value is 1, then it is pi, 2 del, 3 phi, and 4 gamma. Isn't it? So this symbol is known as a capital lambda. In case of atomic stump symbol, it is L, that is 0, 1, 2, 3, 4, and the symbol is SPDFG. But here it is a sigma, pi, del, phi, and a gamma. That is the basic difference between atomic term symbol and molecular term symbol. Spin multiplicity is same, but the lambda value are different. The next one is symmetry. Third one is in place of G value. So here we have considered the symmetry. If G and G means both term is 0, then your symbol will be G. U and U. Unzeroed, unzeroed, then zeroed. Then unzeroed and zeroed, then U. Means plus, 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 minus, minus, plus, plus or minus, minus. So, suppose we consider G is plus, the plus plus G means G into G, G, U means minus, minus, G, that is plus, and U and G, then it is U. Means there are there is only two type of symmetry, by whether it is a G or U. So it can be determined by the symmetry. If symmetry G and G multiply, we can get the G. If U and U multiply symmetry, then we can get G. If U and G, then we can get the U. Now, to determine the ground state of some diatomic molecule, so we have to prepare the term that is the molecule, molecular orbitals, lambda, multiplicity, symmetry, and ground state symbol. So suppose we take S2 molecule ion, hydrogen molecule ion. So hydrogen molecule ion, what is the bonding molecular orbital? So there are bonding and anti-bonding molecular orbital. So one electron present in a bonding molecular orbital, that is in a sigma G 1s. So this is the molecular orbital, sigma G 1s. So electron present in a s orbital means for s electron, ml value is 0. Then what will be the lambda value? Lambda value is 0. Then your symbol will be sigma. So here the one unpaired electron, 1s orbital, one unpaired electron is present, and therefore s value is 1/2. Then our multiplicity is 2. Symmetry, the single electron present in a sigma G orbital, and therefore your symmetries remain same, that is the G, and your symbol will be doublet sigma G. For hydrogen molecule ion, your ground state term symbol is sigma G. Hello. So within 5 minutes I will finish. Okay. Mm. So similarly for hydrogen molecule. So hydrogen molecule, as you know, that electronic molecular orbital configuration is sigma G 1s2, means two electrons are present in bonding orbital. So lambda value is remain same, that is s for s electron it is 0, and the symbol is sigma. Multiplicity is there is no unpaired electron. means the multiplicity is 1. Symmetry, here you can see G into G, that is G, and your symbol will be singlet sigma G. So similarly, one can apply for helium atom, helium molecule. So helium molecule, so there are bonding and anti-bonding orbital. There is sigma G 1s2 and sigma U 1s2. So both electron, all electron are present in a s orbital. So ml value 0. So symbol is remain sigma. So there is no unpaired electron. Multiplicity is 1. So here last electron present in a u orbital, sigma u, means u into u, that is G, and the symbol will be singlet sigma G. So similarly for helium molecule ion. So here one electron less, so there is only one electron in sigma u 1s. So there is no change in a lambda value, but multiplicity is 2 because of one unpaired electron, and the multiplicity is here G into u. That is symmetry is u, and your symbol will be doublet sigma u. Similarly, we can go for a lithium 2. Means there are electronic configuration is there are two bonding orbitals sigma G 2s2, means total altogether there are 6 electron. So last electron, then we have to consider sigma G 2s. So here s electron, ml value is 0, symbol is sigma. So there are no unpaired electron, means multiplicity is 1, G into G, your symbol is singlet sigma G. Similarly for beryllium molecule, there is no s value means s orbital, ml value is 0. There is no unpaired electron, means u into e sigma G. So similarly we can for boron molecule, so here there are 10 electron. So pi u to px and pi u to py, both having a single electron. So what will be the lambda value? So lambda value is ml 0 1 electron, and y ml value, ml value 1 electron, ml value minus 1 electron, means summation ml is 0, means symbol is sigma. There are two unpaired electron, means multiplicity is 3. Symmetry is u into u, that is G, and your ground state will be triplet sigma G. So similarly for carbon molecule ion, so carbon molecule ion, the molecular orbital is pi 2 px 2 electron, pi u to py 1 electron. So here the lambda value is 1, because for ml1 there are 2 electron, ml minus 1 1 electron, summation is 1, and therefore pi. As here for pi x orbital ml value 1, pi y orbital ml value minus 1, and pi z orbital ml value 0. Remember that. So there are one unpaired electron, means multiplicity is 2. Symmetry is u into u, that is G into G u. Finally, it is u. For nitrogen molecule, nitrogen means 14 electron. So here pi u to p x having a 4 electron, pi x and y both having a 4 electron, and pi sigma g, that is the anti bonding molecular orbital of pz orbital. So here sigma value is 0. So there are no unpaired electron. G into G, the molecular term symbol is singlet sigma G. For nitrogen molecule ion, means one electron is less in sigma G to p z orbital. So there are two unpaired electron. Symmetry is remain same, G into G, but the symbol is changed because of doublet sigma G. So here there is a one unpaired electron. So similarly for oxygen molecule, so here pi u to px, pi g to px having a one electron. Pi g to px having a one electron means, so ml value is, and pi y having also one electron, means summation value lambda value is 0 sigma. So there are two unpaired electron, means symbol is triplet G into G G, and therefore it is a triplet sigma G. But in case of oxygen molecule ion, so one electron is less, means Last electron is present in pi g 2px1. Means here the lambda value is 1. One unpaired electron means doublet 2, but let's say 2 g into g, and the symbol is doublet sigma g. So similarly for F2, it is a singlet sigma g, and for F2 ion, there is unpaired electron means doublet pi g because of ml value is changed. Okay, I think I will stop here. From my side, it is over.
Thank you, sir. Thank you so much, sir. Thank you so much, sir, for your information and valuable guidance. It will be very beneficial for all our students and we also. Now, I again request my colleague Shubham Balure, sir, to introduce our next speaker, Professor Dr. Suresh Gaikwad, sir.
Okay, first of all, let me know that am I audible to you all?
Yes, sir.
Okay, so good afternoon, everyone. It gives me an immense pleasure to introduce today's distinguished guest and resource person, Captain Dr. Suresh T. Gaikwad, a name that commands great respect in the field of chemistry and higher education. Captain Dr. Gaikwad is a senior professor of inorganic chemistry, retired on 31st January 2025 from the Department of Chemistry, Dr. Babasaheb Ambedkar, Marathwada University, Chhatrapati Sambhajinagar. With an illustrious teaching career spanning 36 years and 26 years of dedicated research experience, he has made remarkable contributions to academics, research, and university administration. He holds MSc, B.Ed, and PhD degrees and has served in a various responsible positions such as professor, head of department, Director of Student Welfare, Controller of Examinations, Registrar, and the Director of BCUD. His leadership has significantly contributed to academic development and student centric initiatives at the university level. As a researcher, Captain Dr. Gaikwad has published more than 100 research papers, authored 3 academic books, hold a registered patent, and has successfully guided several PhD scholars. His research interests include coordination chemistry, nanotechnology, and catalysis. In addition to his academic excellence, he has served as an NCC officer with the rank of captain, reflecting his commitment to discipline, leadership, and nation building. His outstanding contributions has been recognized through several prestigious awards, including the Devang Mehta National Education Award, Guru Gaurav Award, and the prestigious Dr. APJ Abdul Kalam International Honor Award. We are truly honored to have such an eminent academician, researcher, administrator, and a mentor with us today. I am confident that his presence and insights will greatly enrich this seminar and inspire all of us. Please join me in a giving warm of welcome, Captain Dr. Suresh T. Gaikwad, sir. Thank you.
Thank you so much, sir. Now I will request to the honorable resource persons of today's program, Professor Dr. Suresh Gaikwad, sir, to share his knowledge with us about the topic influence of bioinorganic chemistry on human being and plants.
So first of all, I thanks Mr. Shubham Nagarguje for nicely introducing me.
Thank you, sir.
And first of all, I express my sincere thanks to the Management Council of MSP Mandal and local management council of MSP Mandal Yeshwantrao Chauhan College, Ambajogai District Bid for inviting me. I must thank Principal Dr. Shivdas Shirsat sir, who is my good friend since long back. Vice Principal of this college, Dr. Ramesh Shinde. Professor Dr. M.N. Patel, who delivered just now a very nice lecture on term symbol and its application. This is a favorite topic and very popular topic for M.N. Patel sir. Mainly, this topic is applicable for BSc and MSc students. Mrs. Varsha Nagargoje, who is convener of this one-day national seminar, Mrs. Teju Kople, and all the students' friends. So, good afternoon once again, you all. And actually, Patel sir has taken more than 1 hour, and that's why, without taking much more time in these formalities, may I start my presentation on the given topic, that is the influence of bioinorganic chemistry on human and plant life. So screen is visible for you all, my presentation?
Yes, sir.
Yes, sir.
Okay. May I start now?
Yes, sir. Yes, sir.
So this is the topic of mine, influence of bioinorganic chemistry on human and plant life. So this is a little bit generalized topic, but I want to put before you the significance of inorganic chemistry, particularly in the life of human as well as plant. Okay. So first of all, one, two, three slides are of this type. So in front of you, is it readable for you? Varsha ma'am, is it readable?
Yes, sir.
Okay. So this is the very great scientist who is honored by Nobel Prize in year 2025, Nobel laureate in chemistry. So you try to read yourself also. One of the three, there are three scientists actually. In 2025, those are the recipient of developing metal organic framework, that is in short called MOFs, and known for advancing flexible and functional MOFs, pioneering porous crystalline material with vast application in gas storage, catalysis, water harvesting, and environmental remediation. So if you focus on this particular sentence, and very severe problems we are facing regarding all these things, and they work on this particular issue, and that's why they have been awarded Nobel Prize. So this is first scientist. This is the second one. For the same purpose, for the same cause, they got this particular award. Richard Robson, the 2025 Nobel laureate, who first concept of spacious metal organic molecular construction that later evolved into MOFs, that is metal organic frameworks. Physics world. His early work laid the structural foundation for what Susumu Kitagawa and Omar Wagi later developed into stable and functional MOFs with wide-ranging utility. So these are very interrelated work of these three scientists. So this is second one and this is third one. Omar M. Yagi awarded the 2025 Nobel Prize for pioneering the field of reticular chemistry and developing MOFs, that is crystalline framework, where metal ion are tied together by organs linkers to form porous structure. His work opened a new paradigm in material chemistry, enabling capture of gases like carbon dioxide, water harvesting from air, pollutant removal, and more by exploring metal organic architecture. So you all may be facing the same problem even at your place. So it is said that in general, there is no place in the world which place is free or which is even you see about our capital, that is Delhi. So this is the capital of India, but it is said that nowadays Delhi is not applicable to live the human being. And many times it is said that in this particular period, at least for 1 or 2 months, the residents of Delhi, they must leave Delhi and stay somewhere where oxygen is available in free state. So the pollution of Delhi, pollution of Mumbai, pollution of Pune, not only on these three cities, but all over the world, the problem is similar. And that's why the Nobel Prize awarded to these particular scientists, and all are related to the inorganic chemistry. And that's why I put before you these contribution of these three scientists. So my topic is regarding the inorganic element and plant life as well as human life. So accordingly, I will proceed. So this is a inorganic element, and in that sense, we can say there is a role of these element as a biological foundation. You see, this is the structural role. Inorganic element contribute to DNA stabilization. Family, he बाजूला निघते का बघ बरं थोडंसं. Maintaining the integrity of the double helix structure. You might be knowing the structure of DNA that is just like helix structure. Is it okay? They form key compounds of bone and teeth. Now, bone and teeth, these are very important organ of human being, and which is built by the availability of calcium and phosphate. Is it okay? So without that, there is not possible to build up the bones and teeth. So in that sense, this particular element, calcium and phosphate, significant, and they came from the inorganic chemistry. In that sense, there is an influence of inorganic chemistry in biological system, particularly for human life and plant life. Metal ion helps maintain cell membrane structure, influencing permeability and stability. Another one thing we have to focus, that is functional role. Many biological processes depends on enzyme catalysis where metal act as a cofactor, and example we can indicate the name of that particular element, that is zinc, magnesium, and iron. So you might be realize that how zinc, magnesium, and iron are part and parcel of our life. Another one thing you see, metal regulate acid base balance and pH in biochemical system. Another one thing you can get realize, element such as sodium, potassium, and calcium are essential for nerve impulse transmission. So that's why we are using salt in our diet every day. We are taking NaCl, and that is for the presence of sodium. And sodium is obviously important. Along with potassium and calcium, equally they are important to proceed different type of biological system in our body. Now you focus on this particular aspect, so you may get realize that how inorganic chemistry is significant in our biological system, particularly for human body. So human body essentials by inorganic elements. So these are of two types. One is macro elements. It means it is in large quantity it is required, and another one is the micro elements. It means very micro level requirement of these element is there for the functioning of different type of biological system. And you are aware about different type of biological system in our body. Right from brain system, you can take skin system, digestive system, blood circulation system, uh, respiratory system, excretion system. So large number of systems are continuously going down in the body, and that's why without these elements, without using these elements, without availability of these elements, it is not possible to proceed all these biological systems, or these systems are required for calcium, bone, teeth, nerve signaling is going on. Then magnesium, you see, that is for stabilization, 300 plus enzymes. Another one is uh, phosphorus, ATP and DNA structure. Sodium and potassium, that is for nerve impulse and fluid balance. Even chlorine is also required, that is for electrolyte and acid base balance. So these are macro elements, but these elements are required for the functioning of body system. Another one part, that is micro elements, that is in limited quantity, actually we can say marginalized quantity. So iron, you might be knowing the importance of iron in the body, that is for oxygen transport, uh, that is for hemoglobin and myoglobin. These complex are in our body. Hemoglobin, you might be aware. So hemoglobin is a very complex structure, and at the center there is a metal, that is iron, and iron is bound together all the bioinorganic system or bioinorganic molecules. Even organic molecules are there. So if iron is not there in perfect manner, so that bioorganic system cannot be bound and it cannot be work properly. So whenever you are suffering from some problems and weakness is there, so generally doctor advises to check the blood, and particularly the hemoglobin. So if your hemoglobin is less than 10 or 11, so it indicates that your body is in deficiency of iron, and due to that your body becomes weak. So this is some signals. By taking the characterization or blood checking or blood sample, if you are checking through, so you get some ideas whether some elements are lacking or deficiency, or extra elements are available in the body. So that also happen adverse effect on the body, both the things. If deficiency is there, there is a problem, and additional amount of some elements are stored in the body, that also gives the problem. So another one element is zinc, and zinc is for increasing immunity, body immunity, wound healing, DNA repair. Copper is also there, redox enzyme, collagen formation. Selenium, you see, this is also important element, that is selenium, which act as a oxidant enzyme, and for thyroid activation it is necessary. Generally we are taking through the food, but sometimes there is a deficiency of selenium, so thyroid problems also arises. Another one is iodine, and that is also required because thyroid hormones nowadays, this type of problem is increased in large quantum, and that is due to deficiency of iodine. And that's why whatever salt we are taking in our food, in our diet, so that must be iodized salt, and that only normal salt is banned by the government. Iodine preparation, that is compulsory, that it must be iodized. And you see on every packet of salt, it is written that is iodized salt. So that's why iodine is also required. Another one elements or two elements in macro level, micro level, manganese and cobalt. Actually, these are elements are little bit corrosive and toxic also, but they are required, and that is for bone formation and vitamin B12 function. Now you look to this particular slide, many things you can get realize. This is our body structure, and you all must be aware about this, and how there is a need of different type of inorganic elements for functioning of different bioinorganic systems. This is calcium, this is magnesium, this is zinc, this is iron, this is ATP, this is for H, and this is for bone and teeth. Okay. Now, the description of these all elements and the requirement is given here in short. Now, first of all, you see here why these elements are necessary. What is the significance of this? So, due to deficiency, it may arise anemia, bone weakness, okay, hair loss. Nowadays, you see, in early age, there is a loss of hairs from our head, and we can observe the student of even BSc and MSc many times. Easily, we can observe some students in the class, they don't have hair, or there is a 50% loss, 25% loss of hair. Also, that is maybe due to the deficiency of these elements. So, again, here the same thing is mentioned. One is macro element, another one is micro elements, and their significance or their importance. So you just can imagine without these elements how it affect on the body, and it is shown in this particular circle. These are some representative problems, but large number of problems are there. And in addition to this, you can see this is ultra trace type of elements. It means very trace amount of elements are required in the body, and that is again some toxic elements, and these are chromium, molybdenum, and nickel. So chromium is for insulin function, molybdenum is for enzyme cofactor, nickel is for metabolism. So this is a particular cycle, and that is due to the availability of all type of elements which are maybe required in macro level, micro level, or ultra level, but there is need of these inorganic elements, and that's why it proves that there is a great significance or great influence of bioinorganic system in human life. In short, we can see what happens if there is iron deficiency. So it creates anemia, or it arises this type of problem, fatigue. So there is headache and weakness. Then deficiency of iodine, you might be seen this type of problem in our society. Goiter, metabolism disorder, zinc deficiencies for responsible for hair loss and poor immunity. So accordingly, you can get realize that what type of food you have to prefer. So balanced diet must be there. And in what sense we can call it as a balanced diet? In that particular diet, you must have these inculcation of all these elements. Otherwise, if we are eating only one thing, and uh, some minerals, some vitamins, definitely you will get from that particular material. But as per this particular expectation, you have to eat each and everything. Whatever in the nature it is available, maybe in the form of vegetarian, all type of vegetables, all type of vegetable fruits, all type of non-vegetarian things, maybe fish, maybe chicken, maybe anything. So all things are required, because from each and every different type of vegetables, you may get this type of different elements. Only one type of food or two types of food if you are preferring, so you will not get all these minerals, all these elements. And that's why your diet must be a all-round diet, or we can say in even our Ayurveda also it is said that your diet must be balanced diet. त्याला आपण मराठीत समतोल आहार म्हणतो. समतोल आहाराचा अर्थच असा आहे की ह्या सगळ्या गोष्टी तुम्ही खाल्ल्या पाहिजे, त्या तुमच्या शरीरामध्ये गेल्या पाहिजे. Because each and every type of food, they may contain some different elements, different minerals, different vitamins. Another one that is very important, magnesium deficiency, and this is responsible for muscle cramps and hypertension also. Calcium deficiency, osteoporosis, and weak bones. So this disease, osteoporosis, this is the disease related with the bones. And nowadays the number of patients are day by day it is increasing, and that may be one of the cause, may be due to the deficiency of some elements, calcium particularly. Now you see in pictorial form, this is the indication. Now this is indication of we can say headache. So that is due to the less amount of iron. So fatigue and pale skin. This is vitamin D. So we'll have to take vitamin D from sun. Large amount of vitamin D we are getting in sun. But we have to come out from the home in the morning, early in the morning. Are you going everyone for exercise in the morning at the time of rise of sun? Yes, I want answer from particularly the students. Are you habitual to do exercise in the morning? Somebody can answer me? I will be happy if somebody tell me their routine timetable and saying that I'm going for a walk, going for running, going for playing some games, and I'm getting lot of vitamin D and which is required for overall body. Yes, students, are you listening me?
Yes, sir.
Will you answer? My question is this: are you getting a vitamin D which is coming from the sun in the morning? Actually, I
Yes,
expect
sir.
answer from student. I expect answer from any student. Nobody is there.
Nobody, sir.
Ambedogai is known for sportsman spirit because I am student of Yogeshwari College Ambedogai. I learned there right from 8th standard to BSc final. Even I completed my B.Ed there in the government B.Ed college Ambedogai, which is nearby Yeshwantrao Chauhan College. You know?
Yes, sir. Yes.
Okay. So basically, student must talk. Okay. Next time, I will be happy with interact with the student. So this is vitamin D. Ample amount of vitamin D is available in India. So we will have to utilize the rays of sun in the morning in the duration of 6 to 8 or 6 to 9 a.m. in the morning. So this is freely available. No need to take any tablet for D vitamin. Vitamin B12, due to the deficiency, there is a numbness and poor memory. It affect on the brain also. Iodine, less amount of iodine is there in the body. There is a weight gain and earlier slide, enlarged thyroid also. Deficiency of झिंक, हेअर लॉस अँड फ्रिक्वेंट इलनेस. नेहमी आजारी पडण्याचं कारण सुद्धा हे असू शकतं की तुमच्यामध्ये झिंकची डेफिशियन्सी आहे. अँड दिस वन इज मॅग्नेशियम. दिस इज व्हेरी अप्लिकेबल फॉर youth, that is muscle cramp and irregular heartbeat is also appears due to the deficiency. Now you see, you must have the food habits, and you have to take food which is rich in vitamin D. You see, all these are vitamin D, maybe fish and all these things. So we can get vitamin D in all these things, including sun rays. Vitamin B12 is also available in this type of food material. Iodine is available again. This broccoli is very good for iodine. Okay, and that's why I suggest you can use broccoli in our food. Okay. Even iodized egg is also very important aspect, and you have to take in your food. So iron deficiency, anemia and metabisco is the problem, and for that purpose you can use this particular type of food. There is spinach, त्याला पालक म्हणतो आपण, रेड मीट, फिश सुद्धा आहे त्याच्यामध्ये, देन स्वीट अँड डेअरी प्रोडक्ट्स विच इज iodized properly, then zinc, and due to the deficiency of zinc there is a problem of hair loss and poor immunity. So we have to go through this type of food, you have to prepare this type of food, so you will have no need to take any type of medicine for that. Okay, that is easily available, that is seafood, nuts, seeds, then avocado, legumes, magnesium deficiency, which is responsible for muscle cramp and hypertension. So you can take banana. Banana is very cheap and very everywhere it is available. So banana, avocado, nuts, cheese and leaf greens. ज्याला आपण काय म्हणतो, कोबी म्हणतो ना, फ्लावर, फुलकोबी वगैरे. तर ह्याच्यामध्ये सुद्धा तुम्हाला खूप आयटम मिळतात. हे सगळं तुम्ही खाता का नाही त्याच्यावर तुमचं बरंचसं अवलंबून आहे. आणि खात नसाल सो definitely in future there is a chances of arising deficiency. Now I will give you tips for healthy life. So first one, whatever I told rightly now, eat balanced meal. So your diet must be like this: half plate of vegetable, adequate protein, whole grains. Adequate proteins means generally in India there is a habit to take less protein, but we need large amount of protein and less amount of carbohydrate. But we are eating large amount of chapati, large amount of roti, large amount of rice, but we didn't take more protein. So protein is available in which food, that type of food you have to prepare. And mostly you have to take maximum amount of vegetables. Then another one thing, stay hydrated. Drink 2 to 3 liters of water daily. Are you aware about this? Because our bodies are full of water, and if there is a scarcity of water, large amount of problems arises due to deficiency of water in the body. So if you are not taking 2 to 3 liters of water daily, you start from today. Move your body daily. Now this is the tips for healthy life, and this is my suggestion. This is not my suggestion only. This is a suggestion of our science, because science gives us guidelines how to live healthy life. So it indicates 30 to 45 minutes at least, it means 1 hour minutes of walking plus exercise is required. Another one important point in our life is sleep 7 to 8 hours. Same sleep wake time every day, and you have to have your own timetable of sleeping and get up early in the morning at particular time. So out of 24 hours you must sleep at least 7 to 8 hours, because it recharges your body, and without sleeping you cannot concentrate on your own work. If you are student, you cannot focus on study, you cannot focus on reading, you cannot focus on remembering all the things. So that's why sleeping is the very important aspect in our life. So everyone should try to manage their own routine timetable of 24 hours. Manage stress. Nowadays, the life of human being becomes very stressful, and you have to be stress free, and therefore it is having a part of skill, I can say, that is for deep breathing, meditation, yoga and different type of exercise. So diet for healthy life, all these things are given here. So what amount of things you have to eat? Protein, 1/4 of plate, isn't it? So maximum protein you have to eat, and protein you are getting from which food you have to decide, and accordingly you have to proceed. देन हेल्दी कार्ब्स 1/4 ऑफ प्लेट, म्हणजे तुमच्या प्लेटमध्ये जवळपास अर्धा भाग हा दोनच असले पाहिजे, प्रोटीन आणि हेल्दी कार्ब्स. त्याच्यामध्ये 1/4 1/2 काय असेल, व्हेजिटेबल ऑफ प्लेट, आणि हे बाकीचं जे राहिलेलं आहे ते हेल्दी फॅट्स आर ऑल्सो रिक्वायर्ड, बट दॅट इज इन लिमिटेड क्वांटिटी. सो हिअर इट इज मेन्शन, ईट प्लेंटी ऑफ फ्रुट्स, limit sugar and refined grains, stay hydrated. Stay hydrated means lot of water you have to intake in the body, and follow an eating routine. Okay, you have to fix your time of eating, maybe in the morning, afternoon and evening. So once it is fixed, you have to maintain that. Another important aspects are there, that is number 6, avoid processed food. If you are taking processed food in your diet every day, so that is not good for health. So cut sugar, refined flour and packaged snacks, we can say. So all these things you have to avoid. Now another one thing is maintain your ideal weights. So how to maintain, I will tell you later on in my next few slides. Prevent diabetes, heart disease, and joint issues. If your weight is in under control or in proper ratio, so you will be free from this type of diseases like diabetes, heart disease, and joint issues. And these are very common issues nowadays. Next point is regular health checkup. So you have to check CBC, okay, thyroid, vitamin D, vitamin B12, sugar, and lipid. So nowadays, every human being from India, even they are suffering from this type of problem. That's why you should be aware. And at least once in a year, you have to take total blood count, thyroid test, vitamin D, B12, and sugar and lipid. If there is some problem, so that you will be aware, you will become aware, and you have to take care in proceed. Avoid alcohol and smoking. Nowadays, I observe in particularly youth or student life, they are becomes habitual for this particular habits. So you should be free from all these habits. So, and that is not for sake of your family or everything, but it is helpful to reduce the disease like cancer, liver problem, and heart risk. So alcohol and smoking is always injurious for the health. You should not forget. You should always remember all these things. And last one point, that is build healthy routines. You must have your routine timetable of 24 hours. Once it is prepared, so you will have to follow timetable every day. It means at what time I have to sleep, at what time I have to get it early in the morning, for how much time we have to give for exercise, walking and running, how much time we have to give for reading and some, we can say, hobbies, playing some games. So you have to put on paper the timetable of 24 hours, and accordingly you will have to follow. Just like you are going to school or you are going to college at 10, and college is going on up to 6, so that period is also mentioned there in your timetable. But you should take rest at least 7 to 8 hours to recharge the body, and next day you will be focus on your own job. Now this is in detail I have given. Later on I will send you this particular PPT. I will not go in detail, but just I will uh, give you an idea. First one is care for your diet. Second one is care for your sleep, care for your hydration. The same points, but for what purpose it is required, it is mentioned here. Care for your environment, care for your habits, care for your body, care for your mind, care for your routine, care for your preventive health. एखादा रोग होण्याच्या अगोदर आपण काय केलं पाहिजे, त्याच्यासाठी आपण हेल्दी राहण्यासाठी कुठले कुठले एलिमेंट आपल्या शरीरामध्ये गेले पाहिजे, इनऑर्गॅनिक एलिमेंट पर्टिक्युलरली. सो दिस इज advanced yearly health test for disease free life. So just now I mentioned in the earlier slide, that is complete blood panel. Second one is metabolic organic function test, heart and diabetic screening, and thyroid and hormonal panel. So these tests at least once in a year you will have to go through, check it yourself, so that it give you indication how to live your rest of the life. So women's essential annual tests are also there. So these are some tests for particularly women or girl students. So they must take care of this. Then this is for men's essential annual test, that is for particularly boys and adult gents human being, you can say. Then another one is, that is cancer screening based on age risk. So this is not applicable for even at least once in a year or 2 year once you can go through this particular test. And advanced preventive test also you have to go through sometimes if it is possible. Nowadays this is a protocol. Actually, it becomes a protocol of health science. Nowadays, all type of scanning and imaging is possible. So X-ray or different type of tests are there. You can go through if there is a problem. Lifestyle and fitness assessment you must follow. That is body mass index and body fat percentage. You have to take care of all these. Waist हिप रेशिओ काय असला पाहिजे, तुमचं ब्लड प्रेशर किती असलं पाहिजे, आय अँड डेंटल चेकअप कसं केलं पाहिजे. So these are some tests and the normal range. You might be aware, most of you might be knowing how much iron in microgram per deciliter it is required. So all these things are very must in our body, and that's why there is indication of significance of all these: iron, vitamin D, vitamin B12, iodine, calcium, then magnesium, zinc, TSH, HbA1c. Nowadays, there is a big problem of HbA1c also, because when sugar increase, so if it is less than this particular amount, it is okay. Okay, that is less than 5.7%. Once it is increased, so that particular sugar level or HbA1c try to damage almost all the vital organs available in the body, just like heart, lungs, liver, and every vital organs. So that's why it should not be increase than 5.7. So this is the range of that particular. Okay. Then FBS is also one of the tests. Total cholesterol, it should not be exceed than 200 milligram, and EHB, particularly in women, it must be 12 to 15.5 gram. Okay. So if it is less than 12, it becomes abnormal. Okay. So you might be having a question that what is BMI and how we have to maintain our body weight ratio along with height, and what number, what percentage must be there. So BMI is a simple measurement that tells whether your weight is healthy for your height. It helps to identify. So there are four types of we can classify. One is underweight. Okay, if your weight is less or weight is reduced, that is also not good. Normal weight, overweight, and obesity. So these are the four types of human body. So accordingly, we can easily calculate the BMI, body mass index. So it is having a formula: weight in kilogram divided by weight mid height in meter square. Okay, this is height in meter square. Okay, weight in kilogram divided by height in meter square. So how it can be calculated, you see, just some example. So first one is underweight, that is 18.5. 18.5 means BMI. Okay, BMI categories of adult. If it is less than 18.5, that is indication of underweight. If it is normal weight, it must be in the range of 18.5 to 24.9. So BMI is kilogram divided by meter square. That is in the form of height. Kilogram is in weight and meter square is in height. So you can also calculate just now by using this formula if your range is normal, underweight, or overweight, or you are having obesity. Okay. So you can calculate if you take a page and pen and you just calculate, you put your weight divided by your height in meter. Okay, not in centimeter, in meter. You see if it is in the range of this particular, and I hope you all are students, most of the students and young faculty members. So they must have the range of BMI like this. Is it okay? And if it is not there, you try to reduce or try to gain accordingly and maintain in this particular range your body mass index. Now this is calculation. You see, if height is 160. So this is 160 centimeter. And if we convert into meter, so it will be 1.6 meter. And weight is 55 kilogram. So 55 divided by this meter square, 1.60. So it will be 21.5. Okay. If your height is 165, so you can convert it into meter, that is 1.65, and weight 46. 46 divided by 1.65 square, so it will give 16.9. So one value is 1.5, another one is 16.9. So you see, are it is in this particular range? So one is in range, but another one is not in range. It means 21 is in range, but 16 is not in the range. So if it is less than 18, so it indicates your weight is underweight, and that is not normal. So you can also decide by, so fall in normal weight 18.5 to 24.9 BMI. That is healthy range. And fall in underweight, this particular. Okay. Another example I have given. So you can also calculate your own weight and put your height in meters, take it square. So again, the same thing, BMI and its range. Okay. So why BMI, maintenance of BMI is important? By taking a proper diet, by taking a balanced diet. So BMI helps to detect risk of diabetes, hypertension, heart disease, joint problem, and hormonal imbalance. So if we maintain this, so you can be able to maintain all these problems. Nowadays, it is available portal digital body mass index. So by just touching, you can see your body mass. You just put your feet here, so you will get the reading of your body mass like this. So if you put here just like a weight machine, so on the screen you will observe that is 22.8. So that body mass index is in normal range. Healthy lifestyle increases lifespan. If you want to increase the lifespan, so you must put your body healthy. Now you can take an example of personnel of defense system, maybe in army, maybe in navy, maybe in air force. So it is said that, and there is a survey taken by government, their lifespan is uh, good than the normal people. Why? Because they are having discipline, they are having full of exercise, they are taking proper diet, and that's why the defense personnel, they are having a comparatively good lifespan. They live more years compared to the normal person, and behind that there is a reason. So we also follow balanced diet, minerals, antioxidant, lean protein, daily physical activity, stress reduction, sleep for 7 to 8 hours, regular medical checkup. Metals in medicine, which metals are important to manufacture different type of medicine, different type of drug. So these are some clinical applications. So cisplatin, this is a very popular medicine which is used for recovering the cancer, or we can use as an anti-cancer agent, and it works on DNA cross-linking. Okay. So cisplatin is a medicine. So platinum is the inorganic element or metal in that particular uh, pharmaceutical industry, or that medicine. This another one example, gadolinium complex. Gadolinium is also again inorganic element. So it is used for MRI contrast agent. Okay. Radioactive iodine. This is used for thyroid cancer and hyperthyroidism. Gold complex, in which complex gold is also used, and that is rheumatoid arthritis therapy. Arthritis means again there is a treatment of bone. Then lithium, this is bipolar disorder treatment. So we can realize that how the inorganic element and its influence or significance in the human body. Now we come to the significance of all these elements in plant, particularly the essential elements and its function. So you see micronutrient, so that is nitrogen, phosphorus, potassium, calcium, magnesium, sulfur. So we are producing the fertilizer for a particular crop, and that is only for growth and metabolism. Then micronutrient like iron, zinc, copper, manganese, boron, chlorine, molybdenum, nickel. This is for enzyme activity. Magnesium is chlorophyll core. So I will just describe this chlorophyll pigment. Chlorophyll is again complex, just like the hemoglobin, isn't it? So if you look the structure of chlorophyll, so at the center there is magnesium, and around it large number of biomolecules are bound together, isn't it? So magnesium is a binder. Magnesium is act as a binder. And if magnesium is not there, so that plant development is stopped. Okay. So in photosynthesis, chlorophyll pigment is very essential organ, essential thing. If magnesium is not there, no chlorophyll core is there. Okay. And that's why in plant, the significance of inorganic metal like magnesium, how it is important you can get realized. Iron is also required for plant life, and that is for chlorophyll synthesis and electron transfer. Molybdenum is also required for nitrogen fixation. Nitrogen fixation you might be knowing in botany, you might learn. So that nitrogen fixation is not possible if molybdenum is not there. So in short, in pictorial manner, you can see the slide, and it indicates the role of nutrients, that is macronutrients, which nutrients just rightly now I said NPK, Ca, Mg, S. So that is for growth and metabolism. Micronutrients are these enzyme activities are required for chlorophyll synthesis, electron transfer. So all these things are shown here pictorially. Otherwise, in earlier slide, I described this. Now, soil health and fertilizer management is also required, and there is also the role of inorganic elements. So, this is balanced nutrient supply. Just like human being, we need balanced diet. So, plant also required balanced nutrient supply. तुम्हाला जगदीशचंद्र बोसचा एक गोष्ट सांगितली असेल तुम्हाला बॉटनीच्या टीचरनी, की जसं माणसाला संवेदना असतात तशाच वनस्पतीला सुद्धा संवेदना असतात असं त्यांनी लिहिलेलं आहे, आणि ते प्रूव्ह केलेलं आहे. त्याच्यामध्ये तुम्ही लाजाळूचं झाड जर पाहिलं, सो यू कॅन हॅव एक्सपिरियन्स लाईक दॅट. इफ यू आर टचिंग दॅट पर्टिक्युलर ट्री, दॅट पर्टिक्युलर प्लांट, सो इट गेट कॉन्ट्रॅक्ट. म्हणजे त्याला संवेदना आहेत हे सिद्ध होण्यासाठी हे एक्झाम्पल काफी आहे. आणि त्याच्यामुळं वनस्पतीची हानी किंवा वनस्पतीला त्रास, जसं माणसाला त्रास चालत नाही तसं वनस्पतीला पण त्रास चालत नाही. त्याला जसं डाएट, आपल्याला जसं डाएट आवश्यक असतो तसं वनस्पतीला पण डाएट आवश्यक असतो. सो ओव्हर यूज ऑफ फर्टिलायझर इज ऑल्सो डेंजरस. जसं आपल्याकडं बॉडीला असतं की जास्त एखादा एलिमेंट झाला तर त्याचा सुद्धा प्रॉब्लेम होतो, साईड इफेक्ट होतो, आणि कमी झाला तर त्याचा सुद्धा प्रॉब्लेम होतो. सो हेवी मेटल अक्युमुलेट, lead, cadmium, and arsenic. These are poisonous things, isn't it? Okay. So if there is accumulation, so it will transfer to human being also through vegetables and fruits. So contaminated soil. So it is responsible for crop toxicity, and it indicates for human exposure. So that's why soil testing is essential for sustainable agriculture. For long time, if you want to put your soil proper, so it should be free from contaminants or contaminated. It should not be a contaminated soil. It should be a pure soil, so that it will be useful for farming. So recent Indian case studies, just some example I want to put it before you. So you see, this is very recent thing, recent case. बुलढाणा डिस्ट्रिक्ट महाराष्ट्र, सेलेनियम रिच व्हीट, मास हेअर लॉस. तुम्हाला कल्पना असेल, तुम्ही पेपरला वाचला असेल, टीव्हीवर पाहिलं असेल, की मधल्या काळामध्ये
Any problem, sir? Gaikwad, sir, any problem? Any problem, sir? Gaikwad, sir, any problem?
Madam, Gaikwad sir is disconnected.
Hello? Sir, continue करू का पुढे?
हा सरांना एकदा बोला, नाहीतर मग कंटिन्यू करा मॅडम.
ठीक आहे, कॉल लावून बघते. Gaikwad, sir.
जसे बोला तुम्ही तोपर्यंत मी घेते. हॅलो सर. हा तुम्ही बोला तोपर्यंत. हॅलो.
Sir,
हा 1 मिनिट मॅम, मी दुसऱ्या लॅपटॉपवर जॉईन होते.
okay, sir.
जस्ट 1 मिनिट.
Okay, okay, sir.
तो लॅपटॉप हँग झाला मध्येच माझं.
हा हा.
असू दे. असू दे. हॅलो मॅडम.
Yes, sir.
हा स्क्रीन दिसते का माझी?
हो, sir.
अच्छा. शेवटचं तुम्हाला जोडत आहे. ये करो. मग ये कर. ये बघ. चालेल. राईट राईट. स्लाइड दिसते का मॅडम?
स्लाइड नाही दिसत आहे सर.
नाही का?
नाही.
शेअर केलंय का?
हा शेअर केलंय. मॅडम तिकडे बसलेल्या आहेत. स्लाइड शेअर
नाही चालूच होतं मग ते थोडस डिस्टर्ब झालंय.
बघितलंय का? येस
हा वर्षा मॅडम विजिट आहे विजिबल ना?
येस सर, येस सर.
स्लाइड दिसले ना?
हो हो हो.
हा ओके ओके. So this is I'm discussing regarding this particular case study. So this thing is happened due to the excess of selenium or selenium rich wheat in and there is a cause of mass hair loss. त्या गावातल्या सगळ्या लोकांचे जवळपास 300-400 लोकांचे डोक्यावरचे केस दुसऱ्या दिवशी गायब झाले. So this is due to eating of that particular type of wheat and which wheat they got from the ration. Even another issue recently, just like this issue is happened in 2025. So in 2023, one issue was happened in Bengaluru, and that is regarding the wastewater irrigated vegetable, and heavy metal exposure was there, and a 2023 study by the Environment Management and Policy Research Institute, that is EMPRI, tested 400 vegetables, and all these samples they observed from Bengaluru market. Many vegetables showed evaluated level of toxic metals, and that is like lead, cadmium, chromium, nickel, etc., etc. So all these elements are toxic elements, and due to that toxic elements, along with the vegetables, this incidence was happened. And third one is very dangerous nowadays. That is regarding the toxic metal detected in mother's breast milk. So, in recent years, several small-scale studies from region with industrial pollution, mining activities, and contaminated water sources have reported elevated level of heavy metals such as lead, cadmium, arsenic, and mercury like, and that is in breast milk sample of new mothers. So there is a study highlight the growing environment and public health concern. So this is regarding the contamination of soil, and contamination comes in the vegetables and fruits, and that contaminant is support uh, produced to the human being, and it affect very bad things in the human life. So another one thing I want to put before you, that is the environmental concern, that is regarding the metal contamination. So major source of metal contamination is industrial pollution. You also aware wherever there is industry, so pollution creates, pollution increase. So in this first point, industrial pollution, you can say factories releasing chromium, lead, nickel, and cadmium. That is very dangerous thing. Even from battery, dye, electroplating, and leather industry also it creates pollution. Toxic influence discharge into river and soil. So that also comes to the human being from soil, soil to plant, plant to human being. Another one important Reason is this: mining and smelting activities. So mining dust contains arsenic, mercury, lead. Runoff from mining sites pollutes soil and groundwater. Another one thing is also we'll have to take cognizance, and particularly the students and youth must focus on this particular issue, that is e-waste disposal. Burning of dumping electronics release mercury, cadmium, and lead. So all these are toxic and very poisonous metals and elements. Fine metals particles enter air and water. Fourth point is regarding agriculture contamination. So worries of chemical fertilizer and pesticides. So in generally, farmers are doing overuse sometimes of chemical fertilizer and pesticides. So it accumulate in the plant and fruits. And when we are eating that vegetables or fruits, so definitely the human being or human health affected by this contaminated material. Wastewater irrigated crop absorb heavy metals. So all these plants absorb uh, these particular vegetables, and once we are eating that vegetables, definitely it affect on the body. So contaminated soil transfer metal to vegetable and vegetable to human being. Fifth point is very important, and we all have to take care of that: vehicle emission and urban air pollution. So under this, we have to discuss regarding lead, nickel, manganese from fuel and brake lining. Another one thing is settles on roadside soil and vegetables. आपण रस्त्यावरचे जे सॉइल व्हेजिटेबल किंवा फ्रुट्स घेतो तर त्याच्यावर सुद्धा या पोल्युशनचा परिणाम होऊन इट गेट अक्युमुलेट, अँड इफ वी आर इटिंग दॅट पर्टिक्युलर टाइप ऑफ फ्रूट अँड व्हेजिटेबल, डेफिनेटली इट अफेक्ट. So how metals enters the human food chain? You see, so this is a chain, very simple thing. Soil, once it is contaminated, plants are growing on the soil. So completely human body is dependent on all these things. So whatever food we are taking, so it produces from the soil and in the form of plants, maybe vegetable or we can say fruits. Again, the important question, that is metal accumulate in soil. Plant absorb metal through roots. Contaminated vegetable and grains enters in the market. Human ingest metals daily without realizing. So we are just purchasing the vegetable and fruits, coming to home and eating directly by after boiling. But these metals are unable to boil also, and that's why it enter in the body and it accumulate in our body. So metals also enter through these medium: contaminated drinking water, fish from polluted river, air inhalation near industrial zone. So these are also the medium of getting this contaminated material. So there is a very great compact in between health and environment impact. So accordingly, we'll have to always think about environmental effects on our body, on our soil, on our plants, on our fruits also. Okay. So first one is reduce soil fertility. फर्टिलिटी सॉइलची जी एक क्षमता असते ती नष्ट होऊ लागलेली आहे. उगवण क्षमता असेल किंवा प्रॉडक्ट तयार करण्याची क्षमता असेल. सो डे बाय डे द फर्टिलिटी ऑफ सॉइल इज रिड्युसिंग. टॉक्झिसिटी टू प्लांट, lower the yield, contaminated river, death of aquatic life. Human health effect is also there, that is on particularly organs like uh, kidney, that is of due to cadmium, brain and nerve damage, that is due to lead and mercury, thyroid dysfunctioning, cadmium and chromium, cancer is arsenic and chromium, hormonal and reproductive problems are also there due to these elements. So we have to take care. We are in need of all these elements, but if we are taking large amount of these toxic element in the body, definitely toxicity of the body increases. Poisoning is also happens, and many times death is also arises due to this type of material if we are eating daily. Now, social dimension and public health awareness, how we can maintain. So in short, just within few minutes, I am going to conclude my talk. So I will put before last few slides importance of mineral rich diet. What is the importance? And everybody should take it seriously, read it seriously, and try to remember in mind for a long time. So mineral like iron, calcium, zinc, iodine, and magnesium are essential for growth, immunity, metabolism, and overall health. So it reflects the significance of inorganic material or bioinorganic system in the body. Another one point is there, a mineral rich diet prevents common deficiency and reduces long-term risk of anemia, thyroid issues, bone diseases, and poor immunity. Second awareness point of fertilizer misuse and contamination. So overuse of fertilizer can introduce harmful metal like cadmium, arsenic, and lead into soil and crops. Educating farmers, that is also our responsibility. On balanced fertilizer applications help protect soil health, food safety, and community well-being. Clean water and safe waste disposal reduce exposure to toxic metal and environmental pollution. Active community participation helps ensure safer living conditions and prevent contamination of soil, river, and food resources. Particularly, women, children require targeted nutritional programs. Like women and children are more vulnerable to mineral deficiencies due to biological needs. So, menstruation, pregnancy, and early growth stages, it is also required to maintain, or you have to take special care in during that particular period. So targeted supplementation and nutrition program improve maternal health, cognitive development, and immunity of children. Community responsibility for safe water and safe management is like this. Clean water and safe waste disposal reduce exposure of toxic metal and environmental pollution. Active community participation helps ensure safer living conditions and prevent contamination of soil, river, and food resources. So this is my presentation for you. And once again, just I give one suggestion. Everyone, maybe students, maybe teacher, maybe principal, maybe management council members. So they must have their own timetable right from morning to evening, and even sleeping time is also maintained, so that even though there is a need of different type of elements, inorganic elements, and we have to take elements, but there should not be deficiency. We have to take care, but additional element also it should not be enter in the body by different ways. So that becomes a toxin. So in over limit, everything becomes poison, isn't it? So everything should be in balanced manner, maybe for human being or maybe for plant life. So in this way, I can conclude that influence of bioinorganic chemistry, influence of bioinorganic element, definitely it is there in plant life as well as human life. So thank you. Where inorganic element meets life, science finds its true harmony. Your attention, curiosity helps keep this science alive, and gratitude for being a part of this journey. Thank you very much. And once again, I thanks organizer for inviting me as a resource person for this particular one-day online seminar. Thank you very much. Uh, uh,
Thank you so much, sir, for valuable information regarding the topic. It will be very helpful for us. Thank you once again, sir. Now, I would like to call Professor Shraddha Bemde Madam for vote of thanks.
Good afternoon, everyone. I am here to offer my thanks on behalf of our college. We would especially like to thank Dr. Mohanbhai Patel sir and Professor Dr. Suresh Gaikwad sir. our chief guests, for accepting our invitation and joining us today. Your presence has boosted our energy, and your thoughts have inspired us. All your words have really motivated us. I would like to thank and appreciate our principal, Dr. Shuda Shirsat sir, for always encouraging and directing us. And I would like to thank our vice principal, Dr. Ramesh Shinde sir and PK Zadhav sir. I also want to thank all of you for joining and helping us to make this day successful, and special thanks to all of you. Any event is unsuccessful without a loving and appreciating audience. All people who are attending here deserves a big thank you to all participants and listeners of today's program for your support. Many thanks. Thanks to all of you. Also, special thanks to our technician staff, Ali sir and Asif sir. Thank you so much.
And lastly, very big thank you to all participants and listeners of today's program for your supports. Thank you.